Okay, so hello everyone. My name is Steffi Zegowitz, and I'll be talking about some work I did at the University of Bristol. That work was actually done pre-COVID, and it was on a course called Foundations Improve. And before I go into the details of what I did, I want to tell you a little bit about the course first. So this was a first year UK undergraduate pure mathematics module, and I basically introduced students in the first term of their first year to definitions, proofs, and proof techniques. I had around 300 to 350 students, and the course was assessed via a summative end of term exam. And during the term, there were weekly written homework assignments, but those were formative. So the homework was encouraged, students were encouraged to do them, but it wasn't compulsory. Okay. And so in my second year of teaching, I introduced online quizzes. And so first I'd like to talk a little bit about the motivation behind that. Okay. So there are a couple of observations I made when I first taught the course. And one was that students really seem to struggle with the transition from A-level school mathematics to university level pure mathematics. So I kind of wanted to provide students with an extrinsic motivation to engage with their learning material early on. The other observation I made was that written homework assignments didn't necessarily emphasize the importance of the small details within proofs. So students would have a remark on their homework if they didn't define their notation, but they often didn't realize how the entire proof can fall apart if the notation wasn't defined, for example, in a proof by contradiction. So that was my second motivation. I really wanted to emphasize the small details within proofs. Okay. And to give you a brief overview of the online tests, I designed them to be summative as well as formative. So summative because they counted towards 10% of the final mark. And to me, that was quite important because I kind of wanted students to force them to engage with the material. Yeah. They were formative as well because they would receive individual feedback on the quiz. I decided for them to be open book because I wanted this to be an assessment for learning rather than off learning. So my idea is I really wanted them to engage with their learning material. And by that, I mean to interact with their learning materials, so read through the notes, look at the definitions, go through some examples, and so on. So initially, they were given 48 hours to complete each quiz. But this was later extended to 1 week. And the reason for that was student feedback that I received after the first year. And also it seemed to make sense because written homework assignments always had a 1 week deadline. So it just made sense to extend it also to 1 week. Students could attempt a quiz as many times as they wanted, but they could only submit it once. And basically, previously they had weekly written homework assignments, and I replaced every other assignment with a quiz. Okay, so they alternated with the written homework assignments. I implemented these quizzes on Blackboard. That was because that was the platform of choice for the University of Bristol. And there are some benefits to using Blackboard. One was the automatic marking, which came in quite handy because I had so many students. It supported LaTeX and a variety of question type. It also allowed for automatic feedback that I could tailor to the selected answer choice. So if a student saw a multiple choice question with answer A, B, C, and D, depending on what they chose, they would get a different type of feedback. Okay. I could make the feedback available once the deadline had passed. That was also quite important because they had in the first year 48 hours and in the second year 1 week to complete this quiz. And I couldn't really release the feedback before not everyone had taken the quiz. Okay. Also, I was able to randomize question and answer choices, so each student would see a different version of the quiz. So I could actually recycle some of the questions for the following year. And it was actually really easy to maintain once it was set up. Okay. There were obviously some drawbacks as well, because it did take quite a long time to set up. It didn't support all of the LaTeX packages. It supported the basic ones, but not all of them. The individual feedback didn't support LaTeX, and I used a workaround solution for that. So I had feedback typed up, and I took a screenshot of the PDF and just kind of inserted the image in the feedback, and that seemed to work quite well. There were some display and formatting errors, and some of these were rather strange. And I did speak to the people from Blackboard, and to some of those, they didn't have a solution either. But I did manage to find some workaround solutions. As I said, some of these were rather strange. So for example, I had to insert a blank index for a square root to display correctly. Okay. So it wasn't without hiccups, but once it was set up, it was really great. So let's talk a little bit more about the quiz questions. So there were 7 questions on each quiz. 4 were easier ones and 3 were harder ones. And the easier questions aimed to familiarize students with definitions and to test knowledge. Those were multiple choice questions, multiple answer questions, matching questions, and fill in the blank questions. And we'll look now at some examples. Okay. So this is an example of a multiple answer questions. And if you would like to read these in your own time, the slides are uploaded on Moodle as well, so you can go back to these. Okay. So here students are asked to select all of the statements which are true, and then they're given a list of statements. In this particular example, so this is an actual question from a quiz. It's all about prime numbers and prime factorization. And the next example is an example of a matching question. So here students are given 2 collections of sets, and they're given some answer choices, and they have to match them to the union of the collection of these sets AI, the intersection, and so on. The next example is an example of a fill in the blank question. Here they're asked to find an integer x and using the Chinese remainder theorem. You can see that I added a little bit a sentence, and I said, do not use spacing when entering the answer. That was because it was quite tricky. If a space was entered, then there would be an error message. Okay. But students did quite well following the instructions. I didn't actually have any problems when they took the test. So that all went well. Okay, so let's talk about the harder questions. So the harder question focused on proofs, and those aim to emphasize the small details and also the structure of proofs. And for those, I used multiple choice questions and also matching questions. The matching questions were questions that basically asked a student to arrange a proof in order. So they were given several statements, and then they had to match it to step 1 in a proof, step 2, step 3, and so on. And those questions were based on students' common misconceptions when writing proofs. Okay, so some of these examples include not defining notation, working backwards in a proof, using incorrect assumptions in a proof by contradiction, only proving 1/2 of an if and only if statement, incorrectly forming a contrapositive, using the wrong base case in a proof by induction, or using regular induction instead of strong induction. So these are all examples that were kind of built into the quiz. Okay. So let's look at an example of one of the harder questions. So I hope we can read this. Okay. So here students are given a function f, and then they have to validate proofs. So they have to determine which of the following proofs is correct. So 2 of the proofs show that f is a function, and 2 of the proofs show that f is not of a function, or they claim to prove to prove it. So you probably haven't had a chance to properly read through the example, but I can tell you that the second choice is correct. So this is actually proving that f is a function. And when we look at the first and the last option, that is actually proving that f is not injective. So while it's claiming to prove that f is not a function, it's actually proving that f is not injective. For the first example, it's giving a counterexample, and the last one, it's trying to kind of argue it in general without giving a counterexample. The third option here is claiming to show that f is a function, but this is actually using a proof by example. So I kind of try to incorporate common student errors in these. Okay, so let's have a look at an example of what type of feedback they would receive to this question. Okay, so had they chosen the correct answer choice, then they would have seen an answer feedback like this. So it would have referred to a specific definition in the notes. So students could then read through their notes, look at definition 1.5 and say, okay, there's the definition of what it means for f to be a function. Okay, so basically the feedback says, okay, by this definition, f is a function if such and such, and then it applies it to the example. Then it kind of goes through the idea of what it is that we need to show, and then briefly explains the answer. Okay. Okay, so let's look at some feedback they would have received on an incorrect answer choice. And this was actually, had they chosen the first answer choice, that was that proved that f was injective. So here it starts off in the first part explaining why that particular answer choice was incorrect. And then it also refers back to the definition of what it means for f to be a function. In the second part of the feedback, it would then go through the correct answer briefly and explain why that would have been the correct choice. Okay. Okay, so let's have a look at some of the student survey results. You can see on the chart, I have year 1 and year 2. This refers to the first year of using the online tests and the second year of using the online tests, okay, for the same module. And I basically, in this survey, I asked students to select, they were given statements, I asked them to select which statement they felt applied to them. Okay, so here we can see the results concerning the statement that the online quizzes helped them to engage with the lecture notes early on, and also that the online quizzes helped them to keep up with the material in the lecture notes. Okay, so here we can see the results, and I was actually quite pleased with that, because again, that was one of my main motivation. I really wanted them to engage with their learning material early on. So the second result concerns engagement and feedback. Here we can see in the first year of using these tests, only 44% of students engaged with the feedback. The other 56% either claimed they weren't aware of feedback or that there was feedback available, or they just chose not to engage. And that was quite interesting, because I did mention the availability of feedback several times during lectures and problem classes, and they also had instructions on the same site as they took the quizzes. But I did make a point in my second year of using this to just point it out a few more times in lectures, in problems classes, and so on. And so maybe that's why more students actually engage with them in their second year. Interestingly enough, in the second year or in second year of using these tests in the survey, I asked the students who did not read the feedback why they hadn't read the feedback. And there were kind of three trends. So some said they thought they did well enough to not need to engage with it. They also said that they wanted to do it later on for revision, or they felt it wasn't available straight away, so they just kind of forgot about it. Yeah. Okay, so out of those students who did engage with the feedback, we can see the results that 69% of students in year 1 and 77% of students in year 2 said that the feedback helped them to understand why the answer choice was incorrect. So again, that was really great. I was quite happy with that. So I did ask students about the details within proofs as well. And so I asked them if the online quizzes helped them to pay attention to small details when they were actually writing proofs, and also if the feedback helped them to pay attention. Okay, so again, here you can see the results, and I was quite happy with that, because again, that was one of my motivations. I really wanted to emphasize the small details, and students said it helped them when writing proofs. That was really great. Right, so in the first year when I was using these tests, I was the only one in maths using online tests. And so I did ask students if they would recommend for these to be used in other modules, and 71% of them said yes. So I was quite happy with that. And I did get generally quite very positive feedback from students and colleagues as well. And this actually prompted other first-year modules to introduce online quizzes as well. And now I believe they're also used in higher years. Okay, so what are the conclusions I could draw from my experience? I think the online quizzes successfully achieved their intended goals. Again, I really wanted for students to engage with their learning material, and I really wanted to emphasize the small details. So I think they're a really great complementary tool to traditional written homework assignments. Okay. And while I think that Blackboard isn't flawlessly adapted to mathematics and its notation, I think its use for online quizzes is quite sustainable, at least until possibly a better platform for mathematics has been developed. And so this leads me also to talk a little bit about some plans for future work. And so I'd like to start a project to build an e-learning platform specifically for pure mathematics, which would focus on proofs. And this platform could be used for assessment as well as formative exercises. And when it comes to assessments, there could be pre-programmed proofs for topics in pure mathematics, obviously starting with first year pure maths. And these proofs could be easy to modify, or there are templates for setting up proofs from scratch. There would be formative exercises, for example, practice questions or step-by-step guides through proofs. What I mean by these step-by-step guides through proofs is that the idea is, for example, students are asked to prove that a given function is surjective, then it would ask something like, what is the hypothesis of this statement? And kind of so guide students step by step through the proof, so they kind of get the idea of the structure. What do they need to start with? What do they need to do next? So they kind of get an idea of the different steps in a proof. Automatic feedback would also be integrated, and that would link to relevant definitions. So in that example I just mentioned was the definition of, I think, a surjective function. Also results, so if there was a particular theorem used in the proof, that could be displayed. And also it would link to relevant formative exercises. So if students would want more practice, they could go to these exercises. So if you'd like to chat about this, or if you have any input or tips where I can look for funding for this, please do get in touch. Okay. So again, the slides are on Moodle. So if you want to look this up later on, you feel free to do so. Okay. And this completes my talk. So thank you very much for this opportunity to give a talk.
Okay, thank you very much. Thank you. I think we can appreciate our speaker using the reactions in the chat. And now it's time for questions. I think we have some minutes for questions. Yep. Yeah, maybe, I don't know. Yeah, so there is already a question. Maybe we can take the one straight away on the chat. So the question is, the good mathematical assessment packages out there, can they be adopted for your own purpose rather than starting from scratch? I think, yeah.
Yes, I was actually thinking that. I think because when I, for example, initially did the quiz that was in 2017, 2018, I wasn't aware of everything that was out there. So I think there are a lot of really good plugins that can be used to actually improve this. Rather than also starting from scratch. I think there are a lot of plugins that can be used to start this. Yeah.
Just a follow-up question: do you like use Stack, for example? In Nairobi, will you try Stack? Like, because some of the things you did like can be done by, I think, Stack, or I don't know.
Yes,
Yeah.
I agree. And like I said, at the time when I did these quizzes, I really wasn't aware of Stack and numbers, and but learning more about them now, I think they would have come in really handy. Actually, they would have been really useful.
Yes, Ben has a question also.
Yes, thank you. That was really good. I really enjoyed that talk. So thanks a lot, Stephanie. So the question I have is to do with teaching proofs. So a colleague of mine a long time ago was trying to teach students communication skills in mathematics. And one of the things he used to do was he took a standard proof he got from a book, and he used to chop it up into little bits and then mix it up in a random way, and then get the students to put it back in the right order. Have you ever tried anything like that?
Yeah, so some of the questions were actually they had to arrange a proof in order. And so I kind of took a proof and I separated into the different statements and just kind of jumbled it all up. And then they had to match it to step 1 in the proof, step 2 in the proof, and so on. And the students did actually find these quite difficult, but I think it really helped them, really helped to emphasize the structure.
Yeah, so there is, so Chris, you want to speak on this? No.
Well, thanks, Jared. Stephanie, I sent you an email with a paper that Robbie Bickerton and I wrote last year about assessment of proof online. I'd be very happy to collaborate. It's something that where there's a lot of common ground between institutions. And,
great.
Yeah, thank you for a really interesting talk.
Thank you.
Yeah, so there is, yeah, I think we can take this question from, so great to see that you took this on. It is so hard to write quiz questions for proof, comprehension, etc. And he even had to write meaningful feedback on them. I can see that this helps with proof comprehension. Do you have the impression that it helped with proof writing? Like do you have the impression that it helped the students?
I think it did help them with the proof writing, at least on some parts of it. So I think the quizzes were more meant to be like complementary to written homework assignments rather than just replacing them. They're supposed to, I guess, emphasize the structure of proofs. So I think it did help them with the structure of proof writing, and also with the emphasis on the small details. So I think it helped with certain aspects of the proof writing, certainly. And when I was marking exams in the second year of using these tests, I did really notice No, I mean, in the first year of using these quizzes, I did really notice that they did a lot better with defining their notation, whereas in the first year, when I was teaching it without using the test, it was a really common mistake that they didn't define notation. So there was a real improvement in that. So it was quite noticeable.
Thank you. So I think in case there is another question on the Moodle side, please feel free to take it on. And